Now it's okay. Thank you.
Okay. Thank you, José Manuel, for the introduction, and thank you all for being here in the presentation. Today I will talk about how to integrate ecosystem functioning into ecological modeling. So I will try to explain some advantages and limitations and some case studies. But as we all know, global change threats biodiversity, and we need to take actions to reverse or to halt global biodiversity crisis. So managers and decision makers need to be updated with the best knowledge on the distribution and trends on biodiversity to be effective in the implementation of those actions. So in this context, the GeoBond has introduced the concept of EBVs, essential biodiversity variables, to coordinate global monitoring initiatives and decision making. And species distribution and population abundance has been proposed as EBV candidates because they are easy to measure indicators and intuitive indicators for biodiversity. We can represent the distribution of the species or the abundance through the geographical observations that we can gather from our surveys. But here I want to bring some examples from the Eurobird portal, because it shows the intra and interannual variability on the distribution of these couple of species, which highlights the need of a more dynamic perspective on the species distributions to really understand the processes behind. So the species distribution data mostly came from standardized surveys such as Atlas data, sometimes from opportunistic data, rather than in situ monitoring programs, because these monitoring programs are very expensive and time consuming. So in these areas where we don't have these long-term monitoring programs, we need to support decision making with models and predictions. So species distribution models are one of the main tools used to assess the impact of global change, and also apply to many other with many other applications. So the number of studies using these techniques has exponentially increased. These techniques are basically statistical correlations between the observations of the species with environmental variables. However, the lack of special data on some ecological relevant factors for the species distributions might constrain the potential of these tools for managers and for monitoring purposes. In the last years, we can see that the number of studies using SDMs calibrated with climate data is much more larger than those studies using models fit with land cover information or with the integration of both drivers. And this is really worrying and surprising, because we know that habitat loss and degradation is one of the main threats to biodiversity. So we need to make an effort to incorporate these drivers. And here remote sensing can play a very important role, because offer a broad range of potential candidate variables to be included in our models. As José Manuel already explained very well in his presentation, remote sensing based on the different or specific spectral behavior of the different land cover types. Here we can see the spectral signature of a tree and the difference with other land cover types, which allow us to identify and monitor the different land covers or land use. And nowadays we have a very large number of sensors on board different satellite missions, such as those from NASA and Copernicus. So we have a lot of information with different spectral, spatial, and temporal resolution. In this paper that we published this year in Remote Sensing in Ecology and Conservation, we tried to present a framework to integrate ecosystem functioning and ecological niche modeling. And in this framework has 4 levels of complexity. In the first level, we have already several remote sensing products related with different components of ecosystem functioning, for instance, primary productivity, spectral vegetation indices, which are related with the carbon cycle, evapotranspiration or soil moisture products related with the water cycle, or land surface temperature or albedo, which are more related with the energy balance. So we can take advantage of the high temporal resolution of one of these sensors, such as Sentinel or MODIS, to track from space how one of these components is changing within the year. So we can measure stream values, the quantity, seasonality, a given phenology for different ecosystem functioning attributes, for instance, primary productivity or evapotranspiration. We can also measure then the changes in time. We can measure the change, how it's changing between years to identify trends, anomalies, and even abrupt changes caused by disturbance. So we have a large number here of variables related with ecosystem functioning that can be incorporated in our models, in ecological niche models or other more complex approaches to test different hypotheses or to answer different questions. But why is important for ecological niche modeling? Well, these ecosystem functional attributes can complement or provide additional information about the habitat conditions or the ecological niche of a species. And here I bring a couple of examples. For instance, Requena Muñoz and colleagues were able to map the spatial distribution of the European badger in arid environments using this ecosystem functioning approach. So they found that the variability in primary productivity along the year was a good proxy for the food resources and habitat conditions for this mammal. In this other study, Salvador Arenas Castro and colleagues were able also to predict abundance and also the distribution across different scales for this endemic plant species, the Iris boiseri, which is endemic from the northwestern Iberia. They found also correlation with different levels of productivity as proxy of the habitat conditions, but also with the minimum green days of the year related with the blooming of this plant. We also found that ecosystem functioning influenced the fitness of top predators such as the golden eagle. In this recent paper, we found that the breeding performance of the golden eagles was explained by the seasonal head dynamics measured through the land surface temperature metrics, also affected by albedo and vegetation productivity. So we can track using these indicators how the habitat, especially the hunting and nesting habitat, is changing across time and also among different breeding territories. So we have been testing the ability of these ecosystem functional attributes in SDMs to see the accuracy of the models and also the transferability, so the ability of the model to be extrapolated in space and time. And here we model different species using only climate variables, EFAs, land cover variables, or the combination of these different type of predators. What we found is that the incorporation of this information in ecological niche models help us to improve the model performance and also the transferability. In this study, we provide an example of how we can use, in this case, we model more than 70 bird species using Atlas data and only this type of remote sensing variables. We found that the quality of the models, it depends on the species traits. So for instance, indicators of primary productivity were correlated with the presence of forest habitat species, but for instance, birds nesting in rocky areas were more correlated with land surface temperature or albedo. The limitation of this study was, well, here we didn't have data to test the predictions. We based the accuracy of our models only in cross-validation. So it could be interesting in the future trying to test the projections to see how our projections can support monitoring, and especially in areas where there is no any in situ monitoring program. I also like very much this paper led by Domingo Alcaraz and colleagues. They build models using climate variables and also EFS variables for endangered plant species in Iberian Peninsula. And they compare the predictions of these models. They found contrasting patterns because the EFS variables were able to capture not only the effect of climate on primate productivity, but also the effect of local habitat changes caused by observed land use changes. So we have here a very potential tool also to support recovery plans. For instance, in this case, we focus on the common snipe, which is a bird breeding in wet grasslands. And we need to provide managers and decision makers with maps of priority areas for conservation. So we use a time series of Sentinel-2 to track, to map these grassland dynamics within the year. And we found that the normalized different water index and the standard deviation, annual standard deviation, was a very good predictor of the habitat dynamics. In fact, we can see here the observations, which are very close to the areas with the highest value in the standard deviation. We apply the same framework also to endemic plants in serpentine soils, also in northwestern Iberia. These soils are very rare. That's why there are endemic plants. And in this case, we were able also to model the 3 species using only time series of Sentinel data. So even without considering geomorphologic or topographic information, we were able to map in a very accuracy way the distribution of these species in space and also in time, because in this case, we also have data for a different year. However, despite these all advantages, if we look at the literature, we can see that the number of papers published by the remote sensing community incorporating ecosystem functioning is much more larger than the papers from the ecological modeling community and ecosystem functioning. So it seems that the ecological models are in some way lagging behind the remote sensing community. So as a take-home message, I would like to remark that ecosystem functioning is an important driver of species distribution, but seldom included in SDMs. These variables provide information on the real conditions experienced by the organisms on the ground. So there are several advantages if we compare with the interpolation of, for instance, climate data from meteorological stations, and also the advantages of the high and spatial temporal resolution, which allow us to predict fluctuations, trends, and abrupt changes. As it comes from Earth observation data, and remote sensing technology can be measured systematically. So this facilitates the cross scales and repeatable cost-effective monitoring. And finally, as I said, it's important to bring together the remote sensing expert and ecological models to take the full advantage of these technologies regarding ecosystem functioning and monitoring. That's all. Thank you very much.
Thank you very much, Adrian. Paola write a post in the chat that I always want to send you by email that please give us your list of articles. Amazing timeline. I read it already of them. So very interesting collection. So
yes. In fact, I can. If you go to the article, published in Remote Sensing Ecological Conservation. And you see there are many references, including some of them, not all, because were published this year, some of them. But of course, I can share them in the chat if you want.
Nice, thank you, Adrian. Very, very interesting. And Luis Pesquer puts another comment in the chat. If you get enough profile with Sentinel-2 for creating the essential functional variables. So yeah.
Yes, regarding if I have I guess that this refers to the number of images, maybe because there are using Sentinel A and B, we have an image for almost 5 days. So in this sense, it's much better than Landsat. We have a lot of problems with Landsat. It's almost impossible to create a very good profile in our region because of the clouds and the lower availability of images. But in the case of Sentinel, we just using one per season was enough to really characterize very well the habitat of some of these species. And I think that it could be a very potential satellite for computing